Okay, chapter 19, question 11. Calculate the standard EMF of a cell that use magnesium ion. This electrode and copper ion. That's another pair. These two half cell reacting at 25 degrees Celsius. Also, you calculate EMF. EMF actually is the potential difference between these two half cells. And write the equation for the cell reaction that occurs under standard state condition. So clearly, we need to find the standard potential for these two half cell reaction. So one is copper iron, so copper iron. So be careful. The potential is always a reduction potential, means gain electron reduced to copper matter. So this standard potential is 0.34 volt. While the other half reaction is magnesium ion gain electron reduced to magnesium matter. This half cell potential is negative 2.37. And the reaction, because this is positive, so this is negative, then the reaction is between these two, upper left corner to the lower right corner. Okay. So the actual reaction is copper ion reacted with magnesium metal. Produce copper metal and magnesium ion. And this is positive, because this is more positive, this is more negative, so this is E negative. So the EMF under standard condition will be E0 equals to E positive 0 minus E negative 0, which is 0.34 minus negative 2.37, 2.71 volt. Okay. Next one, question 22. Equilibrium constant for the reaction of strontium metal react with magnesium iron becomes strontium iron and magnesium metal. This reaction's equilibrium constant K equal to 2.69 times 10 to the 12th power at 25 degrees Celsius. As you calculate E0 for this complete reaction, so tell us equilibrium constant. Ask us to calculate E0. Okay. So we know delta G if the energy change for reaction is negative RT, natural log of K. K is equilibrium constant. And this also link with negative N F E. Right. So this gives the energy, equilibrium constant, and the potential energy difference or voltage. These three are linked with each other. So we can calculate the E from this log K. So we use this part. We can calculate the E. So E should equals to both negative, then we can neglect. So RT should be RT over NF times natural log of K. R is a gas constant, 8.314 joule per mole per K. T is the temperature in Kelvin, so convert Celsius to Kelvin. So Kelvin per Kelvin cancelled. N is number of moles of electron. For this case, from strontium 0 to strontium 2, 2 electrons lost. And magnesium 2 becomes 0, also 2 electrons. So this is 2 electrons. F is a Faraday constant, 96500 coulomb per mole. This is 2 mole. Then more per mole cancelled. And K per K cancelled. Coulomb, joule per coulomb, finally give you volts. So natural log of K. K is this number, 2.69 times 10 to the 12th power. Use your calculator. You can get the answer is 0.368 volts. So more per mole cancelled, K per K cancelled, and per mole gone. So leftover joule per coulomb, which is volts, because coulomb times volt equals to joule. During the quiz or test, Faraday constant, I will tell you. And the gas constant also will tell you, so don't worry about this constant. Then question 23. Use a standard reduction potential. So we find this value from a table provided. As you calculate the equilibrium constant for the following reaction. Okay, I just show you one. let's see, let's show you 8. Okay, let's show you 8. Reaction is bromine react with iodide reversible reaction, so we'll have equilibrium constant. Reversible reaction double arrow. 2 bromide and iodine. So we need to find the 2 standard potential from a table provided. For bromine, bromide, this standard potential is 1.07, where for iodide, this one is 0.54. So the actual reaction is bromine be reduced to bromide, where iodide oxidized. So it should be this minus this because this is a reduction potential. So the actual reaction is bromine reduced to bromide. So your standard potential difference should be bromine bromide minus iodine because here is iodide oxidized iodine, so it should be opposite the negative. So the value is 1.07 minus 0.54. Actually, this is 0.53. The standard potential of iodine is 0.53. So the difference is 0.54 volts. Then we can use the equation we just write. Equilibrium constant. Reaction gives the energy is this delta G0 equal to negative RT times log natural log of K. And this also equals to negative NF E0. Right? So we just find E0 from here. So we can calculate the K. Then log K will be NF E0 over RT. Then K equal to E to the NF E0 over RT. And number more is the electron. So bromine to bromine, each bromine gain 1 electron, then 2 bromine gain 2 electrons. If this is more, then 2 more electrons. So 2 times Faraday constant, 96500. This is a coulomb per mole. This is a mole. E0, 0.54 volt. R as a gas constant, 8.314 joule per mole per K. And the T here, then let's see here, 23 at 25 degrees Celsius. So convert it to Kelvin. 25 plus 273.15 Kelvin. Kelvin per Kelvin cancelled. More per mole cancelled. Actually, this is the number of electrons. Okay, more per mole forms is 2 per mole, right? then this Coulomb volt equal to joule. Coulomb times volt equals to joule. So all this unit concept left over on a pure number. Use your calculator, you can easily get this number will be 2 times 10 to the 18th power. Very big equilibrium constant. This means this reaction goes to complete. Yeah, because bromine is more active than iodine, so bromine can displace iodine. Bromine be reduced, and iodine be oxidized, becomes iodine. So the whole reaction goes to complete. Let's show you another, so 24. 8. Or show you one, so 24. 8. Calculate delta G and Kc for the following reaction. A, magnesium metal react with lead iron. Produce magnesium iron and lead metal. As you calculate the delta G and Kc. Okay, similarly as this one, delta G, K, they are linked and also linked with E0. So clearly here also you use E0 to calculate delta G and calculate K, right? So we need at least 2 half reaction. First one is magnesium metal. Actually, so half reaction is must listed as a reduction reaction. So reduction magnesium metal to magnesium iron acts as oxidation. So this is the reduction. So we need to list this first. Lead iron gain 2 electrons becomes a lead metal. This standard potential is negative 0.13 volt. While magnesium iron, let me leave more space. Magnesium iron gain electron becomes magnesium metal. This standard potential is negative 2.37. So this less negative, this more negative. So the reaction is from upper left corner to the lower right corner. So lead iron reacted with magnesium metal produce lead metal and magnesium iron. So in this way, it's very clear. So your E0 of the cell will be E plus minus E negative. So this is a positive and this negative end. Right? So will be negative 0.13 minus negative 2.37. Is 2.24. Then from E0, we can calculate the delta G. Delta G will be negative NF times E0. And number of electrons. So clearly 2 electrons transferred. So 2 electrons transferred. F is Faraday constant and Coulomb per mole. E0 2.24 volt. Coulomb volt is joule. So your answer will be Coulomb volt joule is joule per mole. So use calculator. We can easily get this negative. Don't forget a negative here. So your answer will be negative 43200 joule per mole, or negative 432 kilojoule per mole. And in the same time, we can also use E0 to calculate the K. Okay. So E0, calculate the K. Now we need to calculate the K, right? So K, log K equals to NFE0 over RT. And the K, natural log K equal to NFE0 over RT. And the K equal to E to the NFE0 over RT. And 2 more of the electron, F Faraday constant. E0, 2.24 volt. R, 8.314 joule per mole per K. T is temperature at 25 degrees Celsius. Then convert to Kelvin. Kelvin cancel per Kelvin per mole also cancelled. Coulomb times volt equal to joule also cancelled. Left over is pure number. So this will be a very big number. 5 times 10 to the 75 power. And if you rate the solution of the homework, and you find the solution in homework, we use log K equals to NE0 over 0.0257. The reason is because F Faraday constant, R is gas constant, T is temperature at 25 degrees Celsius. So this F over R and T comes from, okay, this is 0.0257. Comes from F over RT. So F over RT. F is a Faraday constant. R, gas constant. T, room temperature is 25 degrees Celsius, convert to Kelvin. Right? So if you use your calculator, you can easily get, this is a 0.0257. You can either use this, plug in all Faraday constant, gas constant, and the temperature, or you can use this directly. Either way, it's fine. Okay. I wish everybody study hard for the quiz 9 next class. And we finished all content as the syllabus required. So that is chapter Chem 2. The final exam will be ACS standard exam, include the sum from Chem 1. So I wish everybody can make good score on the final.